nerve pulses are controlled by rapid electrical currents. The movement of the electrical current within the neuron is controlled by the relatively positive and negative ions. In resting potential, there is an equal relative charge across the membrane. Sodium ions are outside and potassium ions are inside. However, there are more ions outside the cell than inside, leading to a positive relative charge outside the axon and a negative relative charge inside the axon. A stimulus hits the axon, causing the sodium channels to open. Depolarization is when the inside of the cell becomes positive. This happens when sodium ions rush into the cell through the open channel. It continues until threshold potential is reached. Threshold potential is the critical level to which a membrane potential must be depolarized to initiate action potential. The electrical current moves down the axon as the inside of the cell becomes positive. In the wake of the current, repolarization occurs. Repolarization is the returning of the cell to the resting potential. Sodium channels are closed. Potassium channels are opened, causing potassium ions to rush out of the neuron, restoring positive charge outside the cell. This causes hyperpolarization. Hyperpolarization is a change in the cell's membrane potential that makes it more negative. The sodium and potassium channels are voltage-gated ion channels. They only open or close based on changes in the electrical membrane potential. Currently, there are more potassium ions outside the cell and more sodium ions inside the cell. In order to reset resting potential, correct concentration of sodium and potassium ions must be achieved. Sodium-potassium pump restores membrane potential by pumping 3 sodium ions outside of the cell. At the same time, 2 potassium ions are pumped into the cell. This means that there will be more positive ions outside the cell than inside the cell, creating the correct resting potential charge. No. All amazing drawings done by Priya, all amazing voiceovers done by Kai. The end.